Yes. So we were looking into this, and we were looking into what may be offsets as well. We applied this to captured memory on Solaris, as it happened, because of dtrace. It's very fun, and there are definitely structures there. They are not the primitive structures in that they're not local. They're it's hard to just take a snapshot of a piece of memory, a small piece of memory, and suppress it down to something like the digraph and see them. But there is definitely a structure, and you can see heaps, for example, they stand out. You can see slabs, they stand out. Let's see, I should have given, I will put the pointer to that project, to that student. Again, it's a student project. I will put that project, pointer to that project online. So yeah, we hesitated to bring that here because, first of all, it doesn't really fit with the binary, with the primitive fragments kind of thing. And secondly, there are other people like Dennyquist looking at graphs per se. So if you look at his recon talk or his previous recon talk or his talk here, he used a hypervisor to look at graph structures that you get to see at runtime. And pointers actually do play a role. Mm-hmm. All righty then. Well, yes? That would be the rainfall visualization that Greg came up with. Yes.
So we have done this for network packets as well. The project's older, so it was the RUMINT tool, R-U-M-I-N-T, has a view that will allow, that's where that one picture was generated. It has probably about 20 different views. I haven't worked on it in about 2 years. But it'll handle, well, I switched from network packets over to binaries, so it kind of evolved from there and went down this binary path. But it's out there and the source code's out there too, and it has a variety of different windows in there.
So the problem there is that with the packet, it's hard to determine what the peer group is. So for entropy measures to work, for example, you need to take a distribution. So taking a distribution over a single packet doesn't seem to work so well. So you need to get some idea of the session, but in fact, you're trying to discover what the session is. And so it's a little bit more tricky. But we're definitely planning to do something along these lines later. Let's see how successful we'll be. All right. Well, we're out of time. If you're interested in a graduate degree that disguises hacking as research, as academic research, consider Dartmouth. Consider our lab at Dartmouth. Well, here we go.